Hey guys, so today we're here for the course Electricity 101 and I'm going to tell you what is current, what is voltage and what is resistance, okay? So as you can see here, we've got like all of these things, the quantities here, current, voltage and resistance and the units and types. So we're going to talk about all of these things, okay? So let's get started. What is current? So basically, whenever someone think about current, right, we have this quantity which is known as I. Okay, so I is represented for current. Okay. Now, basically, imagine we have a cross section of a wire. Okay, so this is like a wire that you see like around, right? So I could give you an example, but it's basically the simplest thing that you could think of. It's like probably, you probably had a headphone or something like that. You've probably seen these kind of wires, right? So this is what inside, like you have some current, like some kind of voltage flowing through it. So what happens is, if you think about it, there are some electrons, the particles. What they do is they flow from one point to the other point. Okay, so they start flowing from the battery. Imagine if you have a battery connected here. Okay, so let me just quickly draw a battery up. So no one draws a battery, but I'm just showing it. So this battery, what it's going to do is it's going to pass current through some kind of equipment over here. Okay, so imagine if we put like a lamp or something. Okay, so what's going to happen is the battery is going to current, like power it up, and the current is going to go this way and the electron is going to flow this way. Okay, so there's a confusion over there, so that's not a problem. So now what's happening is the charge is flowing from point A to point B. Okay, so that's what we called current. So now charges definitely flow in time, right? And we represent charges using this letter called Q. Okay, and charges has a unit of coulombs. We represent it with a C. Okay, now whenever we draw like this square brackets, right, so the importance of the thing is we understand that this is the unit. Okay, and so the definition of current is the flow of charge in time. Okay, so flow of charge, or rate of flow of charge, you can say. So that would be Q divided by T, right? So if something is flowing in time, definitely Q divided by T, and which is equals to the current, I equals to Q divided by T. Now here, Q has a unit of coulombs, as we just said here, and as you all know, the unit of time is seconds. Okay, and the unit of current would be then amperes. Okay, we can call it amps as well, like some people like to call it amps because they just short it down. Okay, all right, very good. So we learned about current. Now there's a meter that can measure the amount of current flowing through from one point to the one point. Okay, so this is the circuit symbol of the meter. We call it ammeter. All right, so this is the basic quantity, the first quantity, current. Now we're going to learn a little bit more about voltage. Okay, so what is voltage again? So voltage is basically the driving force of our current. Okay, so our quantity is what? Our quantity is V. All right, V. So here the V quantity represents voltage, or you can say potential difference. Okay, so what do we call it? We call it voltage or potential difference. Very good, you understand. So what does this mean? So it means this is basically the driving force. Let me just write it down quickly. So driving force of current or electricity. Both of them are same thing. Okay, current or electricity. Very good, very good, you understand. Now here we're trying to represent that whenever we saw that wire, let me just draw it again quickly. So whenever we had a flow of electron, the cross-section wire, right, you remember from the previous bit, what's happened is it's flowing from point A to point B, but something is making it go from point A to point B. Like, I mean, electrons are not going to flow by themselves, right? So what's happening is here, electron is started flowing from here, like is usually negative charge, E minus. They start from point A, they go to point B, and this V, or you can say the potential difference, yeah, is basically voltage, is basically our driving factor. If you don't have a voltage in the circuit, that means there would be no current. Okay, so no voltage in the circuit, no current generated. Okay, so that's how the circuit works. So now the voltage in the circuit are usually our batteries. If you have any battery in the system, that is our voltage driver. So imagine you have a cell phone and or like a laptop or something. So would you be able to run the cell phone without like battery? You wouldn't, right? So you can understand the importance of the battery. So battery is basically making the cell phone run. Okay, so you understand the importance. All right, so we learned about current and we learned about voltage. Now let's learn about this one more quantity, what is known as our resistance. We represent resistance as R. Okay, so resistance for R. Very good. So now think about it. We started the current. We learned about the flow of charge. Whenever the flow of charge is happening, taking place, I like to draw this picture a lot. And now there is a way. We learned about the power source as well, wherever this is coming from, right? We have a battery. The battery is generating all these currents and stuff. And then the current is flowing from this. Now imagine you circuit and you want to control the current, right? You don't want to flow unlimited current. So that's why we have this quantity known as resistance. Okay, so the resistance circuit symbol is it could be this one, or you could draw just this one. Okay, so which is represented as R, and the unit of resistance is ohms. Okay, which is from the person who discovered it, whose name is Ohms. Okay, and this guy has a very important law as well, Ohm. So we're going to discuss that in later. Okay, actually I'm supposed to draw it like this. Now this is a circuit symbol where you could draw, like, you could just say 100 ohms or anything. Now in this circuit, what happens is whenever we draw this zigzag, we can understand it. So now our current is going to be flowing from one part to the other. So what happens here, the current is a bit slowed down. So voltage does the work. So this voltage V is going to generate a bit of current, yeah. So it's going to generate current I. The current is flowing through here and going here. This is basically the conventional direction that we understand, we know about. And usually the electron flow in the opposite direction of the conventional direction. Okay, so what happens, the electron has to go through it. It would take more time than the normal area, right? So that means you have to do more work through it. Okay, so there would be a voltage difference. Okay, now if you have more resistance in the circuit, you would have more voltage difference. Okay, so whatever the current voltage you have, let's say, imagine you could say this is 3 volts and the current is going, and you would do some voltage drop over here, voltage drop over here, but these two voltage would be equal to this one, as this is a series circuit. We're going to learn in future about series and parallel circuits. Okay, so stay tuned for our videos, and I will have a quick recap now. So the quick recap is, we learned about I, which is our current, we learned about V, and we learned about R, 3 quantities, right? And the bonus thing for you guys is Ohm's law, which is the main law of electricity. Okay, main law of current, or electricity 101, which is basically this guy discovered the resistance. So this law tells us about V equals to I times R. So if you know the voltage of a circuit and if you know the current of a circuit, and if you know the resistance of a circuit, okay, R1, R2, then you can easily find out what is the voltage of this circuit. Let's say, imagine we don't know this one, we can easily find out using these two things. Okay, and since this is a series circuit, you would add it up. Alright guys, so thank you so much for watching, and if you have any questions, you know who to go to.